Today we are start with a new concept of covalent bonding. In the last class we have discussed about ionic bonding and factors favoring the formation of ionic bond. Now we have covalent bond. What is a covalent bond or how to define a covalent bond? It is the bond formed through the mutual sharing of electron pairs between two atoms. Bond formed through the mutual sharing. While defining an ionic bond, we have to use the word complete transfer. Instead of that word, here we have to use mutual sharing of electron pairs between two atoms. If the first atom give one electron to the bonding, second atom should give one. That is a mutual sharing. If electronegativity difference between the bonding atom is greater than 1.7, that bond is considered to be ionic. But for a covalent bond, this difference in electronegativity should be less than 1.7. So depending on this difference, covalent bonds can be polar covalent or non-polar covalent. Example, in HCl, electronegativity of hydrogen is found to be 2.1 and chlorine is 3. So difference is 3 minus 2.1, that is 0.9, which is less than 1.7. So it is a covalent molecule. But due to electronegativity difference between this hydrogen and chlorine, shared pair of electron is slightly shifted towards chlorine, which make it chlorine slightly negative and hydrogen correspondingly positive. So it is a polar molecule having slight positive charge on hydrogen and equivalent amount of negative charge on chlorine. Such covalent molecules are called polar covalent molecules. If the bonding atoms are of different elements, there is a chance of electronegativity difference and the formed bond can be covalent but polar. At the same time, if we consider hydrogen, here both the atoms are hydrogen. So electronegativity difference between the two atoms, 2.1 minus 2.1, again 2.1. So answer is 0. Electronegativity difference is 0. The sign is difference delta, that is 0. So it is a non-polar molecule. There is no polarity in molecule. Next one is classification on the basis of number of bonds. Depending on the number of covalent bonds between two atoms, they can be classified as single bonded, double bonded and triple bonded. Single bonded, it is a covalent bond in which a pair of electrons is shared between two atoms. A pair, that means two electrons. Sharing of a pair leads to the formation of a single covalent bond. Consider the formation of hydrogen, fluorine, chlorine, etc. Here you have the example fluorine. In fluorine, valence electrons are 7. You can see the 7 electrons, 2, 2, 2 and this one. Here also 2, 2, 2, 6 plus 1. These two electrons which are in red circle, can share with each other, because fluorine contains only 7 electrons in the valence shell. This fluorine accept this one, this fluorine share this one. So these 2 electrons can be shared between 2 atoms, sharing a pair, that is a single covalent bond. But in double covalent bond, example O2, here it is F2. In O2, first oxygen contains 6 electrons in the valence shell, and second oxygen also contains 6 electrons in the valence shell. That means each oxygen is in short of 2 electrons to their stability or to octet. So to attain the octet configuration, this first oxygen accept 2 electrons from second, and this oxygen share electron with first, if you number it as O1 and O2. So sharing takes place between 2 pairs. It is a pair, it is another pair. That is a double bond, O double bond O. Even after the bonding, there is lone pairs, that is 2 here, 2 here, 2 here and 2 here. In triple covalent bond, example nitrogen, 5 valence electrons for each nitrogen. They are in short of 3 electrons to their octet. So 3 electron from second neutron, not neutron, nitrogen, and second nitrogen take it from first. So these 3 pairs are shared, or 6 electrons. 6 electron means 3 pairs are shared. So this molecule is N2, having triple bond between 2 bonded atoms of nitrogen. If we are coming to C2H4, the molecule ethene, carbon contain 4 valence electrons represented by red dots on both carbon, and hydrogen contain 1 electron. As represented, it has the color blue. Each hydrogen need 1 more electron that is available from the carbon, and this carbon need 4 more electrons. Now it has 4. Then 5 from this hydrogen, then it 6 and 2 from the neighboring carbon. In the same way, second carbon take here and coming like this. So when we draw the bond between 2 carbon atoms, you can see 4 electrons, that is 2 pairs, 2 bonds. Between carbon and hydrogen, you have 2 electrons, that is 1 pair, that is single bond. So carbon and carbon connected through a double bond, but carbon hydrogen bond is single bond. So both bonds can be seen in this molecule at the same time. Now see what is coordinate bond. This is another kind of chemical bond. It is actually a type of covalent bond in which shared pair is donated by any one of the 2 bonded atoms. In covalent bond, both atoms should contribute equally, but here shared pair is donated by 1 atom, and the second atom need to give its vacant orbital for sharing. This bond is also known as dative bond, donor-acceptor bond, or coordinate covalent bond. These are other names, and it can be represented by an arrow mark like this. For example, in ammonia, nitrogen has 5 valence electrons and gain 3 more electrons from neighboring hydrogen and completing its octet. Even after completing the octet configuration, this nitrogen has 2 electrons free, or a lone pair, we can say like that. But boron has 3 valence electrons, 3 green dots, and fluorine donate 1 electron each, yellow dots. Totally, boron has 6 electrons in the valence shell. It is in short of 2 electrons, so it is deficient in electron. 2 electrons are deficient. To compensate this deficiency, these 2 electrons can be shared with this vacant orbital of boron. So we can draw like this. Nitrogen donate its shared pair with boron. It is not a transfer of electron, mind it. If nitrogen transfer its electron to boron, definitely that will be an ionic bond. But it is not an ionic bond, it is a kind of covalent bond. So you have to use the sharing. The word sharing is important. But shared pair is given by nitrogen. There is no contribution from boron. Boron gives only its vacant orbital for sharing. In the same way, ammonia can react with H plus ion, proton. Proton has no electron, but for stability, proton needs 2 electrons, or hydrogen needs 2 electrons. So there is also a possibility of coordinate bond, and this is the reason why we are getting ammonium ion. NH3 plus H plus gives NH4 plus.